All right, welcome back. We are going to go ahead and do two examples of a chi-squared goodness of fit test. So we're going to go ahead and start with example 1 here. And the question is, does your zodiac sign determine how successful you will be? Fortune magazine collected the zodiac signs of 256 heads of the largest 400 companies. Is there sufficient evidence to claim that successful people are more likely to be born under certain signs than others? Okay, so let's begin with state. Alright, so we wish to test the following hypotheses. At the 0.05 significance level. Yeah, alpha equals 0.05. Okay. Now our hypotheses are, I'll just write it here. So our null hypothesis, remember, is the observed counts equals the expected counts. So we would say in words, there is no difference in the expected and observed counts of people born, there we go, in the 12 zodiac sign categories. Ooh, I'm gonna run out of room. I gotta start writing smaller, folks. Okay. Fine. Categories. Okay, and our alternative hypothesis would be that there is at least one difference in the expected and observed counts of people born in the 12 zodiac sign categories. There we go. Alright, and that's our statement. That is good to go. So next, let's go ahead and plan. So our plan would be, the bad pen there, sorry. Okay. If conditions, picked two bad pens there. On a roll, folks. Are met. There we go. Green seems to be working for us. Form a chi, should be a fancier X, sorry. You want like a cursive X. Goodness of fit, and do feel free to just write chi-squared GOF test. So our conditions are not normal. That's not one of them. So let's start with random. So does it say anything about these being random? It really, really doesn't. So we would say no statement of randomness we will assume it's random and proceed with caution. And remember, guys, this phrase is your golden boy here. Okay, so first one's a random sample. Second one is a large sample size. All right, so we would have to determine that all the expected counts are at least 5. So how would we find these expected counts? Well, we're gonna take a nice little jump up here and say how many would we expect in each sign if there were no difference between them. So if there were no difference between the signs whatsoever, we're looking at 256 people distributed evenly between 12 zodiac signs. So we would just take the total number divided by 12 because we're assuming there's no difference based on the zodiac sign and how likely you are to be, the head of a company. So 256 divided by 12 is a calculator job. And we get 21.3 repeating. Okay, so the large sample size here, if we take it back, it says all expected counts are at least 5. So every expected count is going to be 21.3. So here we gotta use words. So we would say, if all categories are equal, they have expected counts of, and we'd want to round that up to the nearest whole person. So let's say they'd each have expected counts of 22 people. Which is greater than 5. Alright, last one is going to be, sorry, let me look at it, independent. Independent. So we'd be interested that our sample size is less than 10% of the total population. Now, once again, kind of weird, but okay. So I told you guys that the less than 10% thing is what we're going to use the vast majority of the time. That said, here it's pretty clear what sign you're born under is independent, right? Like, these people's parents weren't collaborating when they were going to have their kids that were going to become, heads of one of the largest 400 companies here. So I feel like it is safe to assume each person's zodiac sign is independent. Yeah, that's a very reasonable thing to assume here. Great. Okay, our plan is complete. We noted that we're proceeding with caution because randomness is not established here. And honestly, if you wanted to focus on the 10% thing instead of actually thinking through it, you could probably get away with that as well. And now we are going to move in to our do. All right. So the first thing we need to do is calculate our chi-squared statistic. So chi-squared is equal to the sum of the observed minus the expected squared all over the expected. So let's go ahead and run through this and kind of create this sum. And I'm not going to write out all 12. Generally, if you have a lot, write out the first two and then do dot, 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 and then the last one. So for the first one, I have my Aries, so they have 23 observed, minus the expected 21.3 squared, all over 21.3. Plus, now I'm going to go ahead and do my Taurus. I'm just going to kind of work down. That would be 20 minus 21.3 squared, all over 21.3, plus dot, 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 plus, and then I'm going to go all the way to Pisces, 29 minus 21.3 squared, all over 21.3. Okay, so let's go ahead and cheat the system here a little bit. So what I would recommend is, instead of typing this into your calculator every time, a lot of the times it's easier to kind of come up with this by just using the list in your calculator. Especially when we start to get really long lists, typing all of these in leaves a lot of room for error. So what I would recommend you do here is, into L1, put your observed values. Into L2, put your expected values, which in this case would be a long list of 21.3s. And for L3, you can put in L1 minus L2 squared over L2. So let me kind of show you what I mean by that. So I'm going to break out my handy dandy calculator here. I'm going to go ahead and just move this right up here. I'm going to go Stat, Edit, and into L1 I'm just going to go ahead and put all of these values. So 23, 20, and go ahead, you might want to follow along here, or just, I guess you can just pay attention, that's cool too. But on the next one, definitely do it. Okay. So that's 12, perfect. So now over here, into each of these I'm going to put my expected value, which is 21, actually maybe I'll just make it simple, 21.3. Okay. So now, if I want L3 to get me all of my chi-squared values that I can then add together, I'm going to go over to L3 and highlight it, and now I can go ahead and put whatever I want in here. So I'm going to do parenthesis, second, L1, which, by the way, is right here above the 1 button, minus second, L2 is right above the 2 button, close the parenthesis, divided by second, L2. And now, ooh, wait, I was supposed to square that. Dang it, let's try that again. Sorry, folks. Second L1 minus second L2 squared divided by second L2. There we go. Alright, so this is like each one's piece of the chi-squared value. And now I just add all these together. So to do that, if we go into stats, our second stat to get into the list, and you go over to math, there's a nice little sum button. So if I want to sum up L3, I get 5.1. You could also, by the way, use 1-bar stats there and just make sure you do it for L3. And the sum is right there, sum of x, 5.10. Alrighty. So this gives me a chi-squared value of, I wish I'd given myself just a little bit more room there. Oh well, I'll just write it underneath. Chi-squared equals 5.10. Alright, now my degrees of freedom is the number of categories minus 1. So there are 12 zodiac signs, so 12 minus 1 gives me 11 degrees of freedom. Now, honestly, I'm never going to make you bother with table C here. You can look up a video on how to use it if you're feeling like it, but highly recommend always, let's just use the calculator. Chi-squared CDF. And this is going to give me my p-value. So I put in my chi-squared statistic, and then my upper bound, which I'm going to make, big, and my lower bound, which I'm going to make 11. My degrees of freedom. All right. So I put this in the calculator, and my p-value equals, let's go ahead and run it, stat test, chi-squared test, ooh, sorry, I gotta find it on here. Oh, my calculator might not be new enough, guys. Let me just double check, but I might not have it. Or I might be going to the wrong spot. Smart. Okay, so second vars, now let's find it. Chi-squared CDF. There we go. So my lower bound, oh, you guys can see what I'm doing here. Sorry about that. So second vars, basic calculator. Okay, 5.10, 1000, and 11 for my degrees of freedom. Alrighty, so this gets me a p-value of 0.9262. Alright, so I'm low on space. I'm going to go ahead and conclude in this next problem's space here. We are going to conclude. All right, and this conclusion, just like our other significance tests, since our p-value is less than alpha, and we got it's greater than alpha, greater than, basic math, folks, is greater than alpha, 0.9262 is greater than 0.05. We fail to reject the null hypothesis. Okay, now let's give it some context. There is not sufficient evidence to show the observed and expected counts of people born in the 12 zodiac categories is different. Alright, and that would be our conclusion. So based on this chi-squared goodness of fit test, we got our chi-squared value of 5.10, degrees of freedom of 11, and when we throw that into our chi-squared CDF, we get a p-value of 0.9262, which is way bigger than 0.05. So we would say, nah, like, you're not more likely to be a certain sign if you're the head of a company. There's no association with that. They're all roughly about even. Okay, I'm going to go ahead and pause this video, and we will resume in our final video and finish up this example too.